So in our continuing saga of making games within Minecraft using it as our game engine, this week we are going to tackle Tetris. Now before the video begins, I want to thank Nodecraft, who has partnered with me on this project, and it's graciously hosting a server to run all these games, so an IP will be linked here. Feel free to join this to play all the games as I make them. This one will be up shortly. I am still kind of in the middle of converting this to work as a plugin, so that way all of you guys can enjoy this. So that will also be up on Curse, hopefully soon. I know I've been really bad about getting that done, but hopefully soon this will be available for everyone to use on your server however you like. Also, if there are any games you'd like to see me try to make, feel free to suggest them down in the comments below. I am looking for new ideas on the next games coming up after this. Anyways, focusing on Tetris now, the first thing to do was to make our playable game board. Now, it first started out sunken in the world, but soon I was able to get it basically eye level with you to make it where it seemed like it'd be the most ideal location for you to play the game at. The next step was to actually add in the pieces. Now, this is an image I would come back to many a times to try and figure out the pieces, how they looked and they rotated. This will come back to this more in the future and how we solve this, but for right now we're just going to do just the T piece and get that to work and use that as our base so that we can kind of continue making the rest of the game and then come back to making the rest of the pieces later. So I started by making a very generic Tetris piece class. This is the class that I hoped would hold all of the Tetris pieces in the future. But for now I just started by hard coding in the T pieces locations of how it was set up and trying to make it as extendable as I could in the future, but for now again just hard coding with that and working with that to make the pieces and give myself a little test demo on the game board. Now all the Tetris pieces, with the exception of the square and the single line piece, they all rotate the same way. They all have one kind of block of the Tetris piece in the middle, which the piece then rotates about. So with that in mind, I kind of just ignored the square and the line and just made the rotation work for just these. The logic for that is actually pretty simple. All you do is you take the X position of the individual piece, you switch that to the Y, and then you do some flipping of the signs, and then you just take the Y position on that little grid and you make that the X. And honestly, if you iterate that over all 9 pieces in most of these cases, it rotates the piece just fine. And if we test this in the world, this is what we get. We get our little T Tetris piece moving around, rotating around when we hit the W key on the keyboard, and it works. Now, you might be asking though, how am I pressing the W key to rotate this piece around? Well, that's what we get to the next bit of this, which is intercepting the player's key presses in order to make things happen. Now, because this is a bucket plugin, it's not that simple. We can't just listen for the player hitting the W key because this is a server-side plugin. So the way we do that is we actually listen for their movement events. So when the player moves, we then have to check which direction that player is moving in order to figure out which key they have pressed. Now, this would be straightforward if it weren't for the fact that forward isn't always the same forward in the sense of the X and Y positions changing. To do that, we need to do some math to figure out how they are actually moving. So the math for this really just comes down to using our trigonometric function friends. Now, I did whiteboard this all out in stream. I'll have this in the background. I know how kind of helpful this will be without me actually explaining in stream what this is all relating to, but I'll try my best here. So essentially what it comes down to is we have a change in X and Y position. That's okay, but it's for the fact that the player can look a different direction and change how those X and Y position changes affect their moving. So say we are looking straight ahead, where ahead is on the X axis, our player's forward movement would look simple as just a positive X and a 0 on the Y. However, if we are now rotated to where we are on the Y axis, in this sense on the 2D plane, a forward movement now relates to a positive Y and a 0X. So simply looking at the changes in X and Y's help us know our change, but we also need to factor in the player's rotation, or in this case their yaw, which is their side to side looking, and we have to use this in order to actually figure out how they are moving. Now, I would dig into more of how this works and kind of explain this better. However, there are a lot of edge cases and there's a lot of things you have to worry about dealing with, especially because when we're dealing with a unit circle, we only care about 360 degrees. However, a lot of this math can fall outside of that, and Bucket also works on the principle of -180 to 180 when it comes to rotation. So there was a lot of kind of edge cases and stuff to handle, but Basically, bottom line is we can convert the player's movement to a sort of angle on the unit circle to where we can then use that to translate that into one of 4 keys depending upon which quadrant it falls in. And with that sort of tricky math solved, we now have the piece moving and rotating on our game board. And unfortunately, it also moves outside of the game board because I didn't limit the positions of which it could go. So after adding some limits to the game board to limit where the piece can move on the game board, we now get the piece moving side to side and not able to extend beyond the walls of the game board. However, when we then rotate the piece on the sides, we can then end up breaking through the side of the game board like so. In order to fix that, however, we would need to check each individual block's collision when we rotate it, see if any of those individual blocks collide with the side walls, and shift the entire piece over if necessary. The next thing to do is to actually make the pieces fall down on the game board to make it more of a playable Tetris style game. To detect when the piece has reached the bottom or has reached another piece, we are actually using the vanilla Minecraft collision detection of checking if a block is at the location we are wanting to move to, and just doing the collision that way. Unfortunately, our first attempt, the piece collides with itself because the top and the bottom would collide when it moves, and you sort of get the picture. So we would need to prevent the piece from colliding with itself. And once we prevent that, the falling and collision detection actually works like a charm, and we have our very first basic concept of Tetris. And what is Tetris without line clearing when you finish a line off? And because we're using vanilla blocks as our sort of full line, it is actually very easy to detect when you have a full line and to clear it. All you gotta do is just go across our game board, check if there is a block at every single location of that line, and then remove that line if so. Now it's a little more complex with this, and you can actually see how I'm doing it all because of my failure to do it correctly with the very top line slowly growing and falling further down. But the way I handle removing lines and even handling removing multiple lines is when we check for a line to be removed and that there is a block in every single position on that line, we then remove that and then scale through all of the ones above it, take them, shift them 1 block down, and then continue our scanning. The time has now come though to implement all of the rest of the pieces. So armed with this picture in front of me in hand, I attempted to add all the pieces into our game. Now, again, for the sake of simplicity, I decided to add them all in, but only the pieces where they are on that 3x3 grid. You can sort of see do rotate the line that's 4 long, and the square, however, do not rotate in the existing game. However, the square doesn't really do anything when it rotates, so you can't really tell. So for the sake of what this game is about to become, there is no rotation on the single line. And now that they've all been implemented and added, I simply just choose a random piece to use for the next piece to drop into play, and we have Tetris. I mean, a very early version that's not complete, one that these lines right here that it's falling can't rotate, but we have nearly a fully playable Tetris game. And if I speed up the video, you will see that it does look like I'm actually playing Tetris. You wouldn't really know that it's not fully complete. That is until I get to the end and you realize there's no end state and the game kind of just sort of bugs out. Now, before we deal with adding the end state, the first thing we need to tackle is adding support for rotating the straight line. Now, I spent a really long time trying to figure out how this is going to work and how to get it to work, until I came across this epiphany. Because yeah, if we rotate, that goes to there, those go up there, just shift down 1, there, rotate, everything shifts down 1, rotate, wait, no. This gives me, oh no, it's just rotate, shift down 1. If you didn't understand what I was talking about in that previous clip, essentially what I figured out is that if we take the exact same logic that we applied to all of the rest of the pieces, and we use the piece that the mouse is currently hovering over as our rotation point, what happens when we rotate about that, every time we rotate there, the piece is the exact same as the one that follows, but it is shifted up by 1. So if we use this rotation, rotate about that point, and then shift the piece down by 1, we get the next piece that is up. Now that we have all the pieces rotating, it's probably also a good time to add in the game's end state. Adding the end state is actually pretty easy, because all we gotta do is when we place a piece down, just check if it's going to intersect with another piece. If it is, then we've hit a point to where we can't actually spawn a piece in anymore because it's spawning in another piece. If not, we are good to go. That's it. I also added in a score system, which is actually a pretty neat idea, because all I did was set these scores into an array where the array index corresponded to how many lines you cleared, and then depending upon which level you were on, we then multiply that value by your level value plus 1. Lastly, all that is left in the terms of Tetris and features that are needed for it to actually be fully Tetris are to have a box which shows the next piece that is up. This was relatively easy to achieve because we just put the piece that was up in that box, and then whenever the piece got placed down, we took what was in the box, spawned it into the game, and then got a new random piece to then put into the box. This is a bad example because it is the same piece like over and over again because that RNG, but as you can see, it does work in the end. And then the other thing we had to do was to add in a box that also held the held piece. This held piece is one that you can swap out with one that is falling and basically make it a piece to where you can have one held, say a good piece, and hold it for when you actually really need it. This was achieved by using the shift key. So again, implementing the intercepting keys, but in this case, the shift key relates to crouching. So we just intercept the crouch event, then send that off to the game. The game then interprets that crouch event to take the piece that's currently falling, put it into the held placement area, and then if there is a piece currently held, it'll swap it out for the piece that's falling. I also decided to get a little fancy with adding in banners that showed text above the held and the next piece up to denote that it being the held box and the next box. This was done via banners which have the ability to have designs on them, and we can implement these designs based upon this website you see in front of me, which shows all the patterns and how you use those patterns to make characters. I then built up a mapping between these patterns and the character to then when we give it a string into the system, it'll convert that string into a banners with patterns that give the letters and then spawn them into the world. Spawning them in, we get banners that look like this, or maybe not. Okay, no, that's still still text. Text, will it show up ever? Maybe no. No, still no text. Well, I mean, here there's text, but like, it doesn't quite look right. Okay, I think we've got it now. The banners, when they spawn the text in, will look like this. There we go. Banners spawned in the world with text on them to make them look like words. Finally figured it out. But there we go. We now have Tetris. All that was left from here was to do some tweaking, bug fixing, and just smaller stuff that is in the final version. But for all intents and purposes, we are done. We have Tetris. It is made. We're done. We're finally done. Hopefully you guys enjoyed. It was a lot of fun to make this. There's a lot of challenges with this, but again, overall, I had fun. This will all be playable very soon on the server that is graciously hosted by Nodecraft. Again, thank you very much to them for partnering with me on this project. Helped me along. Hopefully you guys enjoyed. The plugin will be available soon. I know I've been saying this a lot, but it will be available soon. I promise. I'll be getting it ready enough to where anyone can download this plugin, set it up in your server, and these games are all available for you to use. So, at any rate, there we go. 3 games down. I still have plans for more in the future. If you have any suggestions for games you'd like to see me make, leave them below in the comments. I'll be sure to check them out. Thanks for watching. See you next time. Peace out.